All right. And to using NumPy in your Jupyter Notebook in Python, all you have to do is specify input NumPy, and I'm using a shorter name called MP. MP is this almost standard representation of NumPy. So I import the NumPy library as MP. So everywhere referring to MP dot something, and I'm using NumPy. And the reason I introduced NumPy to begin with is Python itself, Python programming language itself, don't have a definition of array um, to begin with. And Python was in the beginning is not intended to using for numerical computing or data analytics or data science. They just very general computer science people define the compiler, M2 easy to use, very flexible syntax. It's not as rigid as a C program or C++ programming language. It's a very formal language. So Python is kind of a loose and for casual use for people who do not want to remember exact syntax all the time. They want to have a very different way to do the same thing with the flexibility. And adding the NumPy library into Python programming language make the Python programming language as very similar to the MATLAB you've been experiencing in your matrix theory class. I'm not sure if the matrix theory class you guys took is still using MATLAB so far, but almost like a MATLAB. So you don't have to write for loop and or do loop to calculate matrix or vector multiplication or dot product. So make a matrix and vector operation much more simpler, just like a MATLAB language. Also, most of the NumPy functions and library functions are written basically in C and pre-compile it as a library. So as you know, Python itself is not a compiler, it's an interpreter. What is the difference between the compiler and the interpreter? And the compiler actually compile the program, the code you wrote, into a machine executable code, and then just execute it from there. And Python, on the other hand, is called an interpreter. It's basically a script language. It compiles your code line by line while it's executing your program. So interpreter your code as they execute. So many people using Python to program itself. So you write a program to program itself, to change your program. So since it is interpreter, when you change your program, actually it just compiled online, so-called an inline compiler many times. Same thing as a JavaScript is the same thing. They don't compile the entire program altogether to executable code and then run it. And they do line by line compiling while they execute your program. So, of course, so Python, in terms of calculation efficiency, is not as good as a C program. So people say, hey, why don't I write all these numerical computing routine by C and have Python call it as a subroutine or function? So NumPy is one of the major integration between C library into Python. And many other attempt like a SciPy, scientific computing Pi, in Python. It's the same thing. They compile some old Fortran code or C code and other languages code into a interoperable library, so Python can call it as a part of a Python language. So we're going to go through some of those. So don't get me wrong, using Python is for you as a programmer. Just focus on the programming logic, not worry about the efficiency. All the efficiency are designed by Numpy. So here we have, why don't we go through this notebook together, see what kind of Numpy bring onto the table on top of a Python language itself. First, you import the Python Numpy. You move your cursor to the cell and hit Shift Enter to execute that cell. So if you see no error message from here, it means your Numpy library is installed properly. First, we're going to define a Python list. So Python, since Python don't have an array, so they only have a list, you can define the list called L equals to 1, 2, and 3. So this is a Python list. And you can also define a NumPy array called np.array. Remember, the np represent the NumPy. So instead of each time you type out NumPy, now I just type np.array. So I'm defining a NumPy array is also 1, 2, and 3. So it's NumPy array. Okay. So I can list in the for loop. Okay. So all the elements in the L array, and I copy into E, and I print E, variable E, each time for that for loop. Right. And I can actually adding for regular lists in Python, I can add a component using .append function. So here what we have is L.append 4, and then you can list. Now you see the list has 1, 2, 3, 4 instead of 1, 2, 3. So I'm adding one more element to the list using .append function. All right, is this okay? So I want you to comment these things yourself later on. All you have to do is go through these so-called markdown or text cell and press enter. It goes through the original format for you. Now I have 4 prompt over here, prompt sign over here, which is called a headline 4. If I have 2, the character becomes larger and larger. Again, you can hit Shift Enter to execute the formatting. Everybody okay? So the moment you hit Enter, okay, it goes through the editing mode for that cell, and you can add editing mode for that cell. And if you press Shift Enter, it will execute and go to the next line. You see what I'm saying? And if you hit Enter again, go to editing mode. If you hit Control Enter, it will execute that line, but without moving to the next cell. Okay, this is some trick, a keyboard trick you have to do. Okay, now I can append additional elements to a list. However, I cannot do that with NumPy. It'll give me an error. Okay, I will show you how to do the NumPy in a second. And also we can also use a plus operator to execute. I want to show you the difference. This is the plus to append in the list, but plus represent mathematical calculation in NumPy. So here what I'm having is L equals to L plus 5, and that means I'm at, I can add another one here. So if I want to see L is 1, 2, 3, 4, 5. Just want you to follow what I'm doing. Get used to the keyboard and so on and so forth. And you can probably notice that as well. For those cells I executed before and actually has a number in the bracket, for those I haven't executed, they have no number in that bracket, in that cell. Everybody okay so far? Not too difficult? All right. Let's see if I adding this, what happened to property A? Because it give me an arrow, say, okay, this is A equals to A plus 5 and 6. Here, initially, I have this A equals to 1, 2, 3, but now I'm adding 5 or 6. It's not appending to that. So it is trying to execute a so-called numerical. And this is fine, since the original I have 3 elements in this cell. I'm adding another 3 elements. Let's take a look. What is the result of this line? I'm pressing A key to add a new cell in front of me and press enter to enter the editor mode. If you want to get out of editor mode, you hit the escape key and come back to the command mode. Pay attention to the color on the left of that cell with me right now. If you press enter and that cell become, the heading becomes green. If you press escape coming back to command mode, it becomes blue. Everybody okay? Make sense? Make sense? So I can copy and paste a cell as well. You press C to copy and you press V to paste. Okay? Instead of a control C, control V in Macintosh or PC is C and V directly. And you press X to delete that cell in the command mode. C is all in command mode. So C and V, it will make a copy of your cell and press enter to enter the editing mode. I'm going to delete the rest of this line. I just want to print A, see what this looks like. First, shift enter represent the result. And this result actually is equal to 1, 2, 3 plus 5, 6, 7. Everybody see that? Instead of appending 5, 6, 7 as part of the array. All right. So here what we have also, plus means operating, actually mathematical calculation in Numpy. So A plus A equals to 2 times A equals to 2 times every element inside the A array. 2 times L means what? Actually duplicates the array, the list, double, okay? L star supposed to represent the L square, and that's not defined in list. However, it's well defined in Numpy. So just showing you the difference between a list, Python list, and the Python Numpy array. And you can calculate the square, log, and so on and so forth. Are you able to follow my lectures, execute these cell? If not, please raise your question. Okay. Before we're talking about append is the way to adding elements to a list. All I have to do is using plus or using .append function for the list. And I haven't talked about using append function for how to concatenate append elements into the NumPy array. Now we start talking about it, called concatenate NumPy array. So NumPy array, now I have A equals the two-dimensional NumPy array. Pay attention to here. So I'm going to execute this. See, I always click on the from and make it blue, which is currently in command mode. When I hit enter, when it turns to green, now I'm in the editing mode. Okay, so I can change this. Okay, I can change the program now. So I'm trying to calculate this. So NumPy array, execute this line, shift enter. It showed me initially A equals to 1, 2, 3, 4 as a two-dimensional array, 2x2 array. Now, and B is a 5 and 6 is 1x2 array vector. I concatenate A and B together. I want you to pay attention. There's one more option called axis equal to 0. Axis equal to 0 means row operation. Everybody okay? Row operation. So I'm adding one additional row in the A array.
Professor Roy, I got a quick question for you. Jack here. If you put, instead of the axis equals 0, if you put it as axis equals 1, how would that affect that? I think you're muted.
You're muted.
Okay. If you look at the next cell, this is the so-called axis equal to 1. And I'm going to show you what happened. All right?
Yep.
So,
sorry, I jumped again there.
Here what we have originally, before I show you what it is, sorry, mode, go back to the command mode, add a new line. I want you to be able to see that A right now equals to 1, 2, 3, 4. And also, sorry, B right now equals to 5, 6, correct? If I using axis equal to 1, meaning I'm going to adding one more column onto A matrix, but since B is 1x2 vector, I need to transpose them into a column format. Is that okay? So I'm going to transpose the B vector from row vector into a column vector and concatenate together. So let's take a look how that's going to go. So I'm going to NumPy concatenate A and B transpose. So I'm going to make it a column vector and adding to the concatenate, but using axis equal to 1, and that means it's a column operation. So you can see that I'm adding one more column onto A matrix, combine those two together, and I can assign C equals to that, okay? And then I'm going to print C as that. Question for me? So I want to, if this is okay, it's kind of new things for NumPy array, and it's going to be all the same for Panda data frame we're talking about later on. And during the semester, we have a large amount of data set require you to do these kind of concatenate. So you combine two tables together or mash two tables together using certain condition. and either is a row operation or is column operation. So we need you to understand this real quick. And also we're talking about if x is equal to none, what happened? If x is equal to none, it will actually produce a linear vector altogether. So linearize first A matrix, linearize the B vector, and put them into a same linear array. All right, so remember, x is equal to 0, row operation, x is equal to 1, column operation, x is equal to none, equals to linear operation. Okay, here we're going to introduce a NumPy automatically filled in a data option called A range. A range. A range, here I have 8, okay? NumPy A range 8. 8 means what? From 0 to A, but not including A. So all the Python loop, okay, array definition, the end definition, this 8 is not included. The end condition is not included. Let's take a look. It's only from 0 to 7. So you're filling a NumPy array automatically using this function A range from 0 all the way to 8. Okay. And you can also split this array using the X you split into 3. So you have a 3 array. Each one of them has the 3 elements within. So it's an array of an array. All right. Next, I'm going to do the same thing. Okay. What if I only have a 7? So it's from 0 to 7, but not including 7. So I have first 2 array have 3 elements. First array have 3 elements, but the other 2 array have 2 elements because they evenly split it. Okay. So here we have one more time. Now we're going to start talking about dot product of 2 array, which is a vector operation. Vector operation first define an A and B vector, 1, 2, and 3, 4. And in the past, when we calculate dot operation or dot product, what we do is we're using a for loop, okay, calculate A and B, element by element, and add them together. Okay, basically is calculate that. So if I have, execute this, so it's 11, this is dot product. If I do A times B in Python, it actually gives me a 1 times 3 by 2 times 4. It's still 2 elements array. However, also we can do NP sum A times B, it will give me 11. That's the dot product, correct? So I can using Python, NumPy function called dot, meaning dot product, A times B, and it will give me the same thing. All right. Or I can using A dot dot B, give me the same thing. So 2 different formats do the same thing. That's the beauty of Python. Okay, you can call the NumPy function called dot and giving 2 parameter A and B, or you can using directly the subfunction for the A vector. Since A is a NumPy array, it automatically has a dot dot function as well. Question? If not, I'm going to move on. So I'm going to move on a little.
When you do like the for E and F, and zip is just like combining the 2 arrays, right? Or 2. Okay.
getting each element of A and B and propagate it into E and F.
Okay.
Understand? And loop is keep going with element by element.
Right.
I copy the value from A and B and make it into E and F. All right, next we're going to using some of the things we using quite often. We call this sum of a square, basically sum all the elements in the vectors, sum of the square elements of each in the vector, and take a square root. This many times we call the norm of that vector. You probably learned that in the matrix theory. Numpy is fairly simple. What we do is numpy np dot square a times a, which is actually give you a vector like this, 3a basically, and then dot sum, you're summing up all the elements within that vector and return that, and then you take a square root out of it. So let's take a look. This is the result of sum of square. Okay. And also we can using the linear algebra function inside the numpy called numpy np dot linear algebra using a norm function directly, and that give me the same thing. So now you can see we can do the same thing with numpy and Python with very many different ways. So I'm going to show you two applications for using NumPy norm function. Originally, we do this is a so-called cosine angle. Many times, the dot product represent the A function times A vectors norm times B vectors norm divided by the dot product of that is times the cosine of that particular two vector, the angle between that two vector. So the calculation will be A dot B divided by the norm of A and times the norm of B together. So it's pretty simple. Let's execute that and show you this is a cosine angle. And then we can do arc cosine and show you that's the angle we have. Okay, the first is the cosine value, and that's the cosine. Another application I have for you is NumPy array. I just randomly input a NumPy array for 6A, 737, 9, 11, 5, and I calculate the mean for, all right, calculate the mean for that particular array. And called numpy.min. Some of you already know that. We store in the mu. Then I create a so-called arrow vector. Usually we call the arrow respect to the mean. It equals to x minus mu. Okay, x minus mu. So I'm going to print out this. So this is an array, actually a vector of arrows respect to the mean, the deviation respect to the mean, basically. And I'm going to take a mean of that, okay? Take a mean of these average. So I'm going to calculate NumPy linear algebra norm of that arrow term and divide it by square root of what? The length of an arrow vector and minus 1. What is this? This is basically standard deviation, right? So I want you to do exercise yourself. Highlight this cell, type A, insert a cell in front of it, and change this cell from col to Markdown. See that? Okay, just do something so you're not just sitting there watching what I'm doing. So here is to using headline 3, calculating Is that okay? Calculate a standard deviation. And this is how we utilize the norm function and to calculate standard deviation as well. And since you have n minus 1 over here, the length of an arrow minus 1, so this is a sample standard deviation. Okay, we lose 1 degree of freedom because we're using the mu, which is calculated by all the data itself. So lose 1 degree of freedom. I can also using the Numpy, Numpy dot standard deviation. It give me a different number. Why is that? By default, the standard deviation function for Numpy is so-called population standard deviation. So they don't have n minus 1. In order to make the Numpy function to have, you need one more option called degree of freedom equals to 1. So you use up a 1 degree of freedom, so give you the same number. Everybody okay with me? So you know all these from 510, 511, but I'm just showing you how the Numpy and the calculation they make a difference. All right, I want to show you something. This is a small program. I just write it up. And this part is talking about, okay, if I using the dot product, okay, the Python dot product by hand. So I'm using a for loop to calculate the dot product, or I'm using a dot b, which is NumPy calculation. Everybody okay with me? So see what is the difference. If I hand coded this matrix vector dot product, I'm using a function to calculate the same thing, the zip A and B, E and F, do a dot product by hand, okay? Or I'm just applying the dot product function from NumPy, see what is the differences. So I'm going to execute. You can also help join me to execute on your computer. Here I'm using 100 number, randomly generated, calculate dot product. And you can see that from the loop, I'm hand coding this dot product, takes 5.88 seconds. However, if I'm using the NumPy dot product function, it takes 0.082 seconds. So this is where I'm telling you the NumPy is fully optimized code by C language and pre-compiled. So you just have to call it. It gives you the fastest result. In that case, it's about 71 times faster. You see what I'm saying? So that's why I'm telling you why we are using the NumPy instead of hand coding everything in for loop. Okay. Next, I'm going to do a quick function, define a NumPy array 1, 2, 3, 4, and define a list. So, okay, let me show you. So M is a NumPy matrix, L is a list from Python. I can access each element in that array. by using the index 0, 0, 1, 1. So if so give me a different number of that matrix element. And if I define a NumPy matrix, okay, there's 1, 2, 3, 4. I can convert actually a matrix into array as well. All right. So this is the part 1 of our. I want you to go to NumPy stack 2. NumPy stack 2 lecture, giving you a little bit more in-depth additional extension. Some of the things we need to do quite frequently in our data analytics. First is things of how can I generate or create a NumPy array and generate some number into that initially. So first I'm going to call it a NumPy array 1, 2, 3. You know that is generating a vector 1, 2, 3. And second, easily I can do a numpy.0. So I'm going to do a 0 vector of 10 elements. So all 10 elements filled in 0. And if I do numpy 0, 10 by 10, it'll give me a 10 by 10 array matrix. And also I can do a numpy 1, 10 by 10. So it's all filled in with 1. So this is a very handy way to initialize a matrix or array in NumPy using these functions, 1 or 0. Or I can do that with the I. I means identical matrix, okay, with a diagonal of 1, off diagonal elements or 0. So you've done this before. And also, as I do an identity matrix of 10 elements multiplied by 3. So it will give me a vector of 10 elements and multiplied by 3, so all 3 in that case. So you can actually expand on that, which type of a matrix or array you want to generate. And also we can using arange to create an NumPy array is using arange function. Here I have is a NumPy array. I want to create a NumPy array range from 5 to 21, but not including 21. So basically you have from 5 all the way to 20 instead of 21. So please remember this n index 21 is always not include. Doesn't matter is panda later on, for loop later on, also these type of arange. Okay. So this will generate a so-called a vector from 5 all the way to 20. If I do reshape, now I want to make sure they have every 4 elements, I want to separate them into a different row. So now I have a 4 by 4 matrix array, all right? Same thing, if I do 5, NumPy array range from 5 to 21, but not including 21, and reshape it by 4 and divide it by 20. So every element in that array is going to be divided by 20. Make sense? So these are the handy way to quickly create an array. And also, many times we use for training or machine learning, we're using random array. I'm going to create a 10 by 10 random array. So numpy.random and run random. So it's a normally distributed. Okay. If you're using .random, it's normally distributed random number with a mean of 1 and standard deviation of 0. All right. sorry, with the mean of 0, standard deviation 1. If I using random.rand norm, oh, this is 0. Let me do this. Okay, I have made a mistake. Supposedly using .random is a uniform distribution between 0 and 1. I want you to pay attention. So here, make uniform distribution between 0 and 1. Okay. And the next one is called random.random n, which is random normal. This is, make a comment here. With the mean of 0 and standard deviation of 1. That's probably my mistake, so please make a note to yourself. Okay, these are the two ways to generate function. All right, so G is a normal distribution random number. I can calculate the mean and the standard deviation. Everybody okay? Similar to that. If you want to scale or move it, you can always subtract by another mu and multiply by a standard deviation, correct? So you can scale it to any type of a normal distribution. All right. Questions so far? If not, we're going to quickly finish the whole thing. Define a NumPy array 1, 2, 3, 4. Okay. Now we're going to do matrix operation. So first we're going to calculate the inverse of a matrix. We call it linear algebra inverse of A. So it will calculate an inverse. So if A inverse times A from matrix theory, you should know that's probably a identity matrix. Okay, same thing for A times inverse of A. And also linear algebra function determinant, calculate the determinant of A, calculate what? The diagonal of A matrix, okay. And also using diagonal function, actually create a square matrix with diagonal elements defined by 1 and 4. Define A and B matrix. This is outer product and inner product, okay. And diagonal sum, we call it trace. Define it in. We're not using this much, but they all there for you, okay. They are all there. Generate a generate a random normal matrix with 100 rows and 3 columns. Everybody see this? 100 rows and 3 columns. each. And I can calculate the covariances of X. It's a 3x3 matrix. The covariance among each column pair, eigen vector, and eigenvalues. Okay. We'll talk about these later on about eigensystem. Another important operation for matrices or array, two-dimensional arrays in the linear algebra, we want to solve a linear system. We're trying to solve a problem with A times X equals to B, trying to solve for X, usually in regression, linear regression, you learn, you take A inverse times A on both sides, multiply A inverse on both sides of equation. So A inverse times B equals to X, basically. And if you're interested how that markdown cell was formatted, I just hit enter in there. It shows you a LaTeX version of how I compose mathematical equation in here. Define a vector first, B, okay, 1, 2, 3, 4, B equals to 3, 4. And I can do X equals to the A inverse times B. Okay, so it gives me negative 2, 2.5. I can also, using a linear algebra function called solve, this is pretty much follow exactly the MATLAB function, solve, and I can get exact the same answer, either use solve or using A inverse times B. And I have another one. Is A equals to 1, 1, 1.5, and 4. B equals to 2,200 and 5,050. And I can solve for that, and X equals to a function. All right. Next, many times in our data projects, we need to read a whole bunch of data file from CSV file or Excel file. But today I'm going to just show you how to read in data from a CSV file. So we're going to import a function, a library called CSV function along with the Numpy, and I'm going to read this data into a variable called X. I got an error message saying no such file exists, data 2d.csv. But taking a look at my structure, the CSV file, the data file, is not in the same directory in here as I have. But instead, when I download this prerequisite pack, actually all the data organized in a separate data folder called data, okay? So how I'm going to do this using from the current NumPy folder, jump into access the data file from another folder. That's the topic I want to talk about now. Here you say data underscore 2d.csv file, but it's located in a separate data folder. So actually what you see is one, the current directory is NumPy, one level up, but there is a data folder called data with a capital D. So I'm going to see how I'm going to access this. And the first couple of times we're talking about installing the requirement.txt file. You probably learned that already, how we're going to change directly using a DOS command prompt. So instead, I'm going to say here, I'm going to say 1 dot represent the current directory, 2 dot represent the parent directory, which means level up, // and data. slash, meaning current directory is in the Numpy directory. I want to move up one level and change down to data folder and access the data to the CSV file. You see the magic now? So we can actually access a data file in a separate folder. So many times in data projects, you have all your program in one folder or your data in another folder. This is how you access them. Okay, so we can check the type of this data we read in capital X. It's actually a list. You do type X, meaning it show you it's not a NumPy array at all. So how do I convert it into NumPy array? Very simple. All you have to do is an np.array and convert this list, NumPy list, into a NumPy array. Okay, looks exactly the same. However, what I need to do is if I do a type, right now on the X, it showed me that's a NumPy array now. Okay, and we can also read in a data CSV file much easier to read in the huge data set into Append data frame and using Append reading CSV file directly. So then for this, I'm going to import the pandas library as a PD. Okay, with no arrow. That means the panda is already installed. I'm going to read in the data file into a x2 vector and give me another arrow. Why is that? Because I'm in the wrong directory, correct? So one level up slash data folder I have, then reading that data file. The type of X2 is a Panda data frame. And next lecture period in the next week, we're going to start talking about how to manipulate data Panda data frame in terms of rows and columns. So do a X2 info. You showed me what you have 100 numbers, okay, and the first few, and show you the description, actually show you the count, total 100 number. We'll have 3 columns, mean for each column, standard deviation for each column, minima and maxima, 25% quantile, 75% quantile, and maxima value in each column. Okay, so Panda data frame is a much more sophisticated way to dealing with array and matrices, and then we can show you how we can work between the Panda data frame and NumPy array. That will come in the next week. Questions for me so far? Should be fairly straightforward and easy.
Yeah, I have another quick question for you.
Sure.
Let's say if I wanted to open, or if I open this numstack2 and I wanted to run a line in a cell in the middle of the document, is there a way to run all of the cells above it first, or do you have to go through each individual one?
You just hitting this, highlight any of the cells you want to execute enter to, and then I think is run all above. See that?
Okay.
Or you can do run all below. You see that?
Yeah.
And you can also run all the entire notebook. Okay. And the first 3 you already have a shortcut key for it. So Control Enter, Shift Enter, and Alt Enter. See that? And you can also, for me, is for all the output I'm executing so far, I can clear. So all the result is clear from the notebook, and you can re-execute them. Make sense? All right, so these are some few tricks we're gonna learn gradually. I know you're not very familiar with the Jupyter Notebook so far. We will gradually show you how flexible this development environment is. If no question, I am done for the day.